All right. Hi, guys. I wish I was there today, but um, circumstances prevented. So I am going to record this. I hope you do listen. And there's times you're going to want to pause it to um, do pieces that need to be done that need a little more time because I'm just recording straight through. So I'll tell you when to pause, and then I want you to do those things that you need to get done. All right, so this is the last lesson of Unit 3A. So we learned in Lesson 1 the reciprocal identities and the quotient identities, which were basically tangent and cotangent, okay? And reciprocals were what? Sine equals 1 over cosecant, that kind of thing, okay? Then in Lesson 2, we talked about all those Pythagorean identities, which really all came from cosine squared plus sine squared equals 1. And we then manipulated things from there and got 6 different ways to write it. And we're going to use those in today's lesson. So it does say it's called proofs, which I know people get scared when they see that, but this is not that way. So for the bell work, I want you to list all of the identities you know. So we know the reciprocal, quotient, Pythagorean. I want you to write them down. As you noticed in the gateway yesterday, or I'm sorry, on Tuesday, you had to have those memorized. So write them. Someone set a timer, give yourselves 5 minutes, pause the video, and write down all of the identities that you know. Okay, now that you've hopefully done that, hopefully you paused and got those all written, how many total do you have? You should have had 6 reciprocal, you should have had 2 quotient, and then you had the Pythagorean identities written 6 ways. So 9 ways. So you had 9 Pythagorean identities, okay? All right, so now let's use those. We are going to review on Monday, and don't worry if you have questions on this, I will help. There is more practice on this, which if you have time today, you could just start. So that's on pages 8 and 9, and maybe even 10. Yep, and 10 is just reviewing a little of everything. So you have plenty to do today. So we are going to verify an identity using the fundamental identities and the Pythagorean identities. So here we go. Recall that an identity is a statement that says 2 expressions are equivalent for all values of the variable. To verify an identity, we must confirm that the expressions are equivalent through various substitutions and algebraic techniques. This is not the same as solving, okay? That's important, okay? We are not solving a conditional equation. You cannot cross the equal sign. So in this first problem here, well, we're not quite there yet, but actually I'm going to jump. You'll see how we have this equal sign? I like to draw a line because I can change things on one side to manipulate, and I'm trying to make it equal the other. Now you can change both sides to make them kind of equal at some point, but you can't cross the line. So that's what that meant. So guidelines for verifying trig identities. Work with one side of the equation at a time. Try starting with more complicated side. Okay, it gives you more options of playing around with those identities. Look for ways to use algebra or factoring or common denominators, etc. Look for opportunities to use the fundamental identities, reciprocals, quotients, and Pythagorean, and look at the other side of the equation to see what functions you need to have in the end, because that's kind of important, kind of helps you figure out, where should I start with this, or where am I trying to get with this? And if all else fails, try converting all terms into sine and cosine, okay? Because we know those the best. So let's do this. If I look at letter A here, and I am trying to verify 1 minus sine squared x over cosine x, and I tell you that side ends up equaling cosine x, I need to prove it. Okay, so since this side is the smallest, I'm not even going to adjust it. I want this side over here to end up being cosine x. That's our goal. All right, so let's make that happen. Well, here is one of our Pythagorean identities. I know that 1 minus sine squared x equals cosine squared x. So my numerator changed. In the denominator, I still have cosine x. Okay, that's awesome. So now I have two cosines on top and I have a cosine on bottom. So some things cancel. So since I'm not there to like kind of point and show you, remember cosine squared is the same thing as saying cosine x times cosine x. And I have this all over a cosine x. So one cosine x in the numerator and one in the denominator cancel and leaves me with cosine x. And I said it equals cosine x because that's just bringing that one down. So there, I just proved that those two things equal. So that's what we're doing today. Some of these are a little difficult to get to or tricky or whatever. You've really got to think sometimes outside the box, but with all the things that we've learned. And so they get frustrating until you figure it out. And then you feel like, oh, that was awesome. I figured it out. So just be patient if you're not seeing it right off the bat. All right, so obviously my easy side here is 1. Well, a lot of things equal 1, so I'm not changing that side. I want this to eventually say 1 equals 1, okay? So let's see what we can do here. Well, both of these, let's see, I have a secant over cosine. Well, remember, 1 over cosine, well, I guess we're using theta in this problem, equals secant, right? So this first parenthesis really is the same thing as saying secant times secant on the top. So I have, oh, I can't even write. Sorry about that. Secant squared theta. Okay? Because let's see, if I rewrite this top, I had secant theta in the numerator. The denominator became secant theta as well, because is 1 over cosine. Okay, so that became secant squared. I know I have a lot of writing and I'm sorry, it's probably not making sense over here. Okay, ooh, I'm getting a lot of extra stuff. So then we have this tangent theta over cotangent theta. Well, I know tangent theta is the same thing as saying sine over cosine. Remember, it says if all else fails, just try to change everything to sine and cosine, right? Now, cotangent is the same thing as saying cosine over sine, but this is in the denominator, so cosine stays in the bottom, and sine now is in the top. Okay, so and it's a minus sign in between. So this, I'm just going to leave this as secant squared, minus. Now I have a sine and a sine in the numerator, so that becomes sine squared. Denominator, I have cosine squared, because there was 2 of them. So let's see where we can go from here. Well, I have a secant, and there's a Pythagorean identity that has secant squared and tangent squared together. Well, look at this. Sine over cosine is tangent, so sine squared over cosine squared is tangent squared. So let's go ahead and change that. So if you look back on your previous page, let's see, that would be page 4, where we have the tangent squared and the secant squared. I know that tangent squared plus 1 equals secant, and then I had 1 equals secant squared minus tangent squared. So this right here equals 1. And I just proved that identity. Okay, let's try it again. And feel free to pause these anytime if you need more time to do it, okay? So here we have cotangent theta over secant theta equals cosecant theta minus 1. So here, I don't want to cross the line. I can simplify each sign. This is not cosecant squared theta minus 1. So we cannot use a Pythagorean identity there, because all the Pythagorean identities have the trig functions being squared. So this is what I'm trying to get this left side to equal. I can't do anything with this secant theta minus 1 besides change cosecant to 1 over sine. And that's not helpful in this case. So we're just going to deal with the left side here. So let's separate this out. So I have a cotangent in the numerator, and I have a secant in the denominator. Okay, and remember that's like cotangent over 1. Okay, it's the same thing. I just rewrote it. All right, so let's see what we have this equals. I know cotangent is the same thing as saying cosine over sine. Okay, that's one of those quotient identities. And then I know 1 over cosecant, that's a reciprocal identity, is the same thing as saying cosine. Well, in the numerator now, I have cosine times cosine, which is cosine squared, all over sine. Well, again, let's see what we can do. I know that, okay, so let's keep going, sorry. All right, oops. So I have cosine squared over sine squared. And let's see, we know cosine squared, Pythagorean identity. I'm already starting to see, I actually think there's a typo in your practice. And no, you can't just change problems. But I think I made an error when typing this out. I actually think this is supposed to be not a -1. I think it's supposed to be minus a sine theta. So go with that for now. Let's just change that. Sorry, I had to look for this for a second, and I was like, I think I made a mistake. Okay, there we go. So change the problem. You don't get to do that normally. Don't feel you get to do that in the practice. All the practice ones I know work out very well. Okay, so we know that cosine squared theta, Pythagorean identity, says that that is the same thing as saying 1 minus sine squared theta. And I have that still over sine. Okie dokie. So let's factor out the 1 over, well, let's separate it out. So I have 1 over sine minus sine squared over sine. See, this is where that's coming in. Okay, this equals cosecant. I have minus, and I have a sine squared over sine, which eliminates the squared and the one on bottom and leaves me with the sine theta. And that is where I get this solution. I just realized that was a typo. I have it written on my paper with that change, and I forgot to tell you to make that change from the get-go. So this side equals that side, and we have verified that identity. Okay, so come over here. Oof, this has got a lot on the left side. So here's our line we don't want to cross. This is pretty simple, so I'm just going to leave it as is for now. We're going to try to get that left side to be that. So let's see what we know. We know, I have sine and cosine on the left. So let's just change things on, I have sine and cosine on the right. So let's change everything on the left to sine and cosine. So I know that tangent is the same thing as saying sine x over cosine x minus, and then I have, this parenthesis here. So, or this division here. So let's say secant is the same thing as saying 1 over cosine. So I know I have a cosine now in the denominator. And then I still have a sine on the top. Okay, that was taking care of this and this. Cosecant squared is 1, well, if you think of 1 over cosecant squared is the same thing as saying sine squared in the numerator. So let's just move that up there. Whoops, it's not theta this time, it's x. Okay. So that took care of this, because remember, it's the same thing as saying 1 over cosecant, cosecant squared. All right. So now we've got lots of sines and cosines, but I can see both of them have this in common. So I'm going to factor that out. Sine x over cosine x. Okay, whoops, not subtract. So I'm going to have, if I take this and I take out sine x and cosine x, I'm left with 1. And then I have minus. Then I'm taking this out and I'm left with sine squared x. All right, so I just factored that sine x over cosine x out. I basically factored out tangent of everything. Okay, so we know that this is a Pythagorean identity. So I'm still going to leave this sine and cosine here. But in parentheses now, I know that cosine squared equals 1 minus sine squared. Okay? So I have a cosine in the numerator, because this is really like over 1, right? So I have cosine squared in the numerator, a sine in the numerator, and a cosine in the denominator. So I can cancel this cosine with one of these cosines, so I don't have it squared. And now I'm left with, in the numerator here, I'm left with sine, and it's multiplying by the cosine that I have left. And that equals what I was trying to get, sine x, cosine x. There was my identity. Okay, here was the next one. So divide it up. So this time we have to pick our side. What are we going to try to do? Now, you can make it so you maybe want to simplify one side and then make the other side meet it halfway if you feel you must. So far we've just been leaving one side of it completely alone. But that's not what you have to do. You just can't cross that equal sign. That's why I draw these lines, okay? So you could, change this side up to say, oh, well, I know this equals 1 over sine x cosine x. It's the same thing, all right? Well, then maybe that's where I stop on this side. So let's just do that, okay? All right, so let's change this. I know that cotangent is the same thing as saying cosine x over sine x. And I have plus tangent, which I know is sine x over cosine x. All right, now we can multiply or take any of our pieces and multiply it by 1. Like, that's not changing the equation, and that's not doing something to both sides. I just know I can take this and I can multiply just it by 1, and it doesn't change my thing. So I'm going to say my goal is to leave the sign. Basically what this is showing me, I want everything in the denominator. Okay, so let's look at this. Let's make common denominators over here. So let's do, and we want that to be sine and cosine. That's what this is saying, right? So to have a common denominator, I have a denominator of sine, I have a denominator of cosine. So let's make this one sine here. I'll do a different color. Maybe that'll make more sense. Sine x over sine x, okay, because that's really just 1 times that. I didn't change the problem. That's why we can do that in just that one part. And then over here, oh, I'm sorry, guys, it wasn't sine. That's what happens when you do this when you're sick. Okay. I wanted the denominator to be sine times cosine. This already had the sine. All right, so I'm going to multiply this first one by cosine over cosine. So it's just taking it times 1, which we can do to anything. And I want this denominator to be cosine and sine, so I need to multiply by sine and sine, okay? So this top here gave me a cosine squared. And now the denominators are the same, so I'm just going to write them out. Okay, and then on top I have the plus, and this is sine squared. And we know the beauty of those Pythagorean identities. We know that this equals 1, and I still have sine x cosine x in the denominator. And look, with what I changed that right side to, they now equal. Now I could have taken this a step farther and made it equal this, but like I said, you can make them meet in the middle. And so in this case I did. So there you have it. So your job today is to complete page 7 in your packet. It has those guidelines to remind you at the top. There's only 4 problems to identify. If you get that done, then I want you to go over to, and you can start page 8, 9, and 10. You don't feel you have to get done with that because we'll also have Monday to work on that. So have a great day, and I hope you guys enjoy your 3-day weekend.